Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Every technician, administrator, and network engineer eventually faces a moment where access to the right infrastructure tool makes the difference between solving a problem in minutes and wasting hours. When dealing with routers, switches, firewalls, or any network-connected hardware, having the means to connect, configure, backup, and restore devices is critical. Whether you're performing proactive maintenance or reacting to a network outage, infrastructure tools like TFTP servers, terminal emulators, and common command line interface utilities are essential. They enable access to system internals, streamline troubleshooting, and ensure configurations can be saved, transferred, or recovered when needed. In this episode, we focus on the practical tools used in network support and diagnostics. You'll learn what the trivial file transfer protocol is, how terminal emulators facilitate device access, and how to work with common CLI commands like ping, traceroute, and interface status checks. These are the tools every field technician and support professional needs to master. They're lightweight, widely available, and easy to overlook, but they make up the foundation of most day-to-day network troubleshooting. Let's start with TFTP, or Trivial File Transfer Protocol. TFTP is a lightweight method of transferring files between devices on a network. It runs over UDP port 69, and unlike FTP or SFTP, it does not require authentication or support encrypted communication. Because it is simple and efficient, TFTP is often used for transferring device configuration files, firmware images, or boot code to and from switches and routers. In short, it's a go-to protocol for fast, automated, low-overhead file operations within a trusted local network. TFTP has several key use cases. One common example is backing up and restoring device configurations. Network administrators frequently use TFTP to save a router's current configuration before making changes, or to deploy a standard config to multiple devices. Another use is firmware upgrades. When a switch or access point needs a new image file, the upgrade is often initiated using a command line directive that pulls the firmware from a TFTP server. FTP is also used in scripted tasks during staging, imaging, or recovery of devices that don't yet have full management capability. Despite its utility, TFTP has limitations and associated risks. The biggest concern is its complete lack of authentication or encryption. This means any device on the same network can request files, or worse, upload unauthorized versions. For this reason, TFTP should only be used in secured local networks or behind isolated staging environments. Additionally, because it uses UDP, it lacks the session management and reliability of TCP-based protocols. FTP is easily blocked by firewalls, especially at network perimeters, and is often restricted in enterprise environments due to its insecure design. Another critical tool category is terminal emulators. These software applications provide command line interface access to network hardware. Through them, you can configure switches, routers, firewalls, and other devices using console ports, SSH, or Telnet sessions. Terminal emulators simulate a serial or network terminal and display command output in real time. Popular terminal emulators include PuTTY, TerraTerm, SecureCRT, and These tools allow you to connect to devices using serial cables, establish secure SSH sessions, or log in over Telnet when supported. One of the most common scenarios for using terminal emulators is accessing a device via its serial console. This method is often necessary during initial setup, especially when the device has no assigned IP address or is offline due to misconfiguration. Serial console connections use RJ45, USB, or DB9 cables depending on the device. When connecting over serial, the terminal emulator must be configured with the correct COM port, baud rate, data bits, parity, and stop bits. Mismatched settings can result in garbled output or no display at all. Once a device is on the network, SSH becomes the preferred method for secure management. Unlike Telnet, which sends all data in plain text, SSH encrypts both commands and responses, including login credentials. SSH is considered the standard for remote CLI access and is supported by virtually all modern network devices. Using SSH protects your session from eavesdropping, man-in-the-middle attacks, and session hijacking. SSH can also be used for tunneling, file transfers via SCP or SFTP, and remote command execution. Several basic CLI commands are used repeatedly in network troubleshooting. Ping tests connectivity between hosts, revealing basic reachability and round-trip time. Traceroute or traceroute maps the route packets take across networks, helping identify where delays or failures occur. Show interfaces displays interface status, error counts, and bandwidth utilization. Show IP route reveals routing table entries, connected networks, and learned routes from dynamic protocol. Finally, copy running cog startup CG is used to save current device configurations, ensuring that changes persist after a reboot. Understanding the output of these commands is key to effective diagnostics. The show interfaces command can reveal whether a port is administratively down, whether it's receiving excessive errors, or whether the link has flapped recently. Error counters, like CRC errors, input drops, or collisions suggest physical or layer 2 problems. Show IP route can indicate whether a specific subnet is reachable, whether it's learned via OSPF, EIGRP, or is statically configured. CPU and memory usage can also be observed through show processes or show system, depending on the platform. Terminal emulators also offer features for scripting and session logging. Logging is useful when performing changes. You can capture a full record of commands entered and the responses returned. This is helpful for audits, post-incident analysis, or training. Scripting capabilities, often found in tools like SecureCRT or Terraterm, allow you to automate repetitive tasks like pushing configs to multiple devices or gathering specific outputs. Some emulators support expect-based scripting languages, which wait for a specific prompt before sending the next command. This speeds up routine maintenance and ensures consistency across devices. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Backing up configurations using TFTP is a standard task for network administrators and one of the most straightforward use cases for the protocol. On Cisco devices, the command copy, running cog, TFTP, initiates the backup. You'll be prompted to enter the IP address of the TFTP server and a file name for the saved configuration. It's essential to verify that the TFTP server is running, reachable from the network device, and allowed through any local firewall. Once saved, configurations should be labeled clearly with the device name, date, and purpose. These files are invaluable for rapid restoration after device failure or during audits and change control. Restoring from backup is just as simple, but it must be done carefully. The command copy TFTP running cog pulls the file from the TFTP server into the device's active memory. Depending on the content of the file, changes may take effect immediately, especially if interface configurations or routing tables are involved. After loading a config, always verify the integrity and contents. Commands like show running or ccomgog or show interface status help confirm that the expected settings have been applied. Some restores require a reboot or manual intervention to reinitialize services. Always validate before walking away from the session. Firmware upgrades using TFTP follow a similar workflow. The new image file is placed on the TFTP server, then the device is instructed to download it to local flash storage. The command copy TFTP flash, followed by the file name, initiates the process. Once downloaded, the device can be told to boot from the new image using boot system commands. As with configurations, always verify the integrity of the file using MD5 or SA checksums if available. A corrupted image can render a device inoperable, especially if the upgrade involves the bootloader. TFTP makes these tasks lightweight and fast, but requires careful attention to detail. In real-world fieldwork, infrastructure tools are used in combination to perform complete troubleshooting and recovery operations. For example, if a switch fails and boots into recovery mode, a technician may connect using a terminal emulator via serial console, upload a known good firmware image using TFTP, and apply the backup configuration using CLI commands. Each tool plays a role: terminal access for control, TFTP for file transfer, and command line commands for verification and management. Being fluent in all three is what separates junior technicians from confident troubleshooters. Of course, these tools come with challenges. TFTP, for example, is often blocked by default on firewalls due to its unauthenticated nature. Port 69 must be open, and the protocol's use of UDP makes it harder to track or verify. Console access via serial may be disrupted by selecting the wrong COM port or using an incorrect baud rate, often 9600 for older devices but higher for newer ones. File transfers may fail if the TFTP server has the wrong permissions, if the file name is misspelled, or if the file path includes unsupported characters. Most of these issues are resolved through patient, step-by-step validation. Best practices for infrastructure access begin with using secure protocols whenever possible. Telnet should be avoided in favor of SSH, which encrypts both credentials and session data. Passwords should be strong, unique, and changed regularly. Access should be logged and limited to specific devices or subnets using ACLs or management VLANs. Documentation is just as important. Record usernames, saved configurations, firmware versions, and changes made during troubleshooting. These notes help future technicians and provide a trail for compliance audits or post-mortem reviews after major incidents. The Network Plus exam includes many scenarios involving these tools. You might be shown a snippet of CLI output and asked to interpret what's happening, for example, identifying that a device is running from a backup image or that an interface is administratively down. You may need to select the correct command to back up a configuration, recognize which tool is used for remote access, or identify the cause of a failed file transfer. Knowing what each tool does, which protocol it uses, and how it integrates with others is crucial for success both on the test and on the job. To summarize, infrastructure tools like TFTP, terminal emulators, and basic CLI commands are not flashy, but they are absolutely essential. They're the backbone of hands-on networking and enable both planned maintenance and fast recovery. Whether you're accessing a router for the first time, pushing a config change, or recovering a switch from failed firmware, these are the tools that get the job done. Mastering them not only improves your efficiency, it prepares you for nearly every scenario you'll face in network operations. Your ability to move between console access, file transfer, and command line management with confidence is a core skill. Knowing when and how to use TFTP, how to initiate terminal sessions, and which commands deliver the insights you need gives you the power to solve problems efficiently and thoroughly. These tools won't be the most glamorous part of your toolkit, but they will be some of the most frequently used and most heavily relied upon in real-world support and on the certification exam. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.